evaluate the following limit. Limit tan 2x by x minus pi by 2 as x tends to pi by 2. So this is going to be tan of 180 degree and tan 180 is 0. So numerator is 0, denominator is 0. So we have to somehow manipulate it to get a expression that will suit one of this. Right? That's the agenda. So when we have pi by 2, we get the result in the form of 0 by 0. Now, how will we do this? See, the thing is, in all of this list of formulas, we have the constant tending towards 0. Agree? It's not equal to pi by 2 and all of that. We don't have that. It's tending towards 0. So we need to convert this to something, some constant tends towards 0. The only way that we can do here is, one of the ways is, we need to substitute. We'll substitute what? We'll substitute the expression which will turn this to 0. So in this case, the substitution will happen with x minus pi by 2. Right? So you will get a hint of all of this in the expression itself. What is that we need to substitute? So in this case, we need to substitute x minus pi by 2 as h. So in this place, we are going to make it as h. Of course, we need to substitute for x also. So we'll get an expression for x by rearranging. You'll get h plus pi by 2. Now, when we do this, it's not only the variables that will change, it is also the limit that will change. So x as it tends to pi by 2, in this case we are pushing x towards pi by 2. So h will move towards what? That is the question. So let's see this. I have the function h. Of course, here it's written as f of x, but you can imagine it is a function of x, but with the name of h. So h of x, you can imagine it to be h of x, which is equal to x minus pi by 2. Now, similar to what we used to do, like x tending to 3.14 by 2, that is 1.57. So I'll push the x value towards 1.57. So let's see what happens. So we can see 1.575, that's good enough. So it's going towards 0. Right? See, similar to whatever we handled when it came to your polynomial expressions. If I take it as a polynomial question. So we end up with what? We end up with substituting pi by 2 over here and h will be equal to 0. So h will tend towards 0. So all in all, we can tell that even the limits has to change. And this is how we change the given limit to tend towards 0. Okay, so this is how we do it. So we have limit h tending towards 0 tan of 2 times of x is h plus 2 times of pi by 2. This entire thing divided with h. You guys agree with that? And so we have 2 and 2 getting cancelled, and this is limit h tending towards 0 tan of 2h plus 2 into 90. Pi is nothing but 2 into 90 in terms of your degree divided by h. But we know that what is tan of 2 theta? Actually, this step was not required. It doesn't matter. Okay, let me actually cancel it off. This step was not required, guys. We can directly do this. Okay, let's analyze the numerator. Tan of 2 into 90 plus theta is of this form. So we know that this is even. We can see that clearly. and this turns out to be in third quadrant. So what do we have? We have this to be, since it's in third quadrant, it will be positive. Since it's even, it will remain to be tan, and we have this as tan of theta, right? So this entire expression will turn into limit tan of 2h by h as h tends to 0. So what identity we have to make use of? This, right? But we have to have the same expressions in the numerator and denominator, but we don't have. So what should we do? We'll multiply and divide with 2. And so we'll end up with limit tan 2h by 2h into 2 as h tends towards 0. This entire expression will become 1. So 1 into 2 is 2. And that's your result.